All right, everyone, good morning. I wanted to start out this morning by having you imagine something. I would like you to imagine what California would have looked like thousands of years ago. The wilderness stretches out before you, from mountaintops to sandstone canyons. We don't have to buy a time machine to go to this place. We must only take a boat ride to Santa Rosa Island. Santa Rosa Island acts as a time capsule for what California might have looked like, and boasts endemic species that have since become extinct on the mainland and are now unique to Santa Rosa Island. I'm going to give you a bit of background on where CSU, or where the Channel Islands are, but first I want to introduce myself. I am Austin, and I'm representing my research group from CSU Channel Islands, go Dolphins. And I'm going to be presenting to you photo point analysis, which is an interdisciplinary approach to cataloging ecological restoration through photography. So for those of you who do not know, the cluster of islands off the coast of California right here is what we call the Channel Islands. The national park is the area shaded in green. This particular area is also named the Galapagos of North America due to its rich biodiversity, which is in part fueled by its isolationism in its evolution. I'm going to zoom in a little bit so I can show you the island in particular that I'm referring to. It is the second largest of the islands, called Santa Rosa. This east area of the island is where all of the hikes for photo point analysis take place. The hike that I'm specifically going to show you today, I will switch over to satellite view. You can see that the area I'm going to be presenting on today has a canyon. You can see there's going to be a beach area. And the reason why I chose this area to present with you guys today is because there's a lot of data to share, and I wanted to share the most diverse. And Lobo Canyon Hike has the most diverse terrain. Santa Rosa Island's road to becoming a national park was not linear. Its inhabitants starts with the Chumash and their ancestors before they were removed by the Spanish during the Mission era. Then, after the Mission era, ranchers took over Santa Rosa Island, where they introduced many different invasive species, many of which were livestock. The livestock overgrazed the island and destroyed a lot of the local environments, including a lot of the native plants that exist on Santa Rosa Island, many of which are endemic and can be found nowhere else in the world. Once it was taken over by the National Park in 1986, its goal was to restore many of the native and endemic plants so that future visitors to the islands and other researchers can continue to enjoy the uniqueness of the Santa Rosa Island. Currently, the National Park boasts wilderness, campgrounds, marine reserves, and the Santa Rosa Island Research Station, or SRIRS, which is also co-facilitated by CSU Channel Islands. For my methodology, I'm going to be immersing you guys in the environment using 360 photography, which was taken by an Insta-1 camera. I want to add that none of these photos have been altered for accuracy. So I'm going to start off by telling you guys a little bit about my field data collection methodology. It starts out with small teams of hiking groups, often citizen scientists, which are visitors to the Santa Rosa Island Research Station, or students of CSU Channel Islands themselves. They start out on designated hikes that have been predetermined by the National Park System and are equipped with a GPS, a compass, a camera, and a meter stick for scale. The compass is used to point the hikers in the right direction for taking the photo. In this specific waypoint, I'll show you that there's actually multiple different photos that are taken in this one location, and so the compass helps to replicate accuracy between the photos. After the photos are taken, that's where my main job comes in. We take the photograph information. There's two different types of photograph metadata that I use. One of which is automatically generated by the camera, and that's GPS coordinates, dates, times, and dates and times. And then From there, I also use the spreadsheets that are also given to the hiking teams, which include photograph descriptions with specific language also determined from the national park. And then I use all of that metadata, put it into a content management system called Omeka. And through that content management system, I can look at the photographs through time and use qualitative differentiation to look at environmental trends over time. The length of this project is 2 years so far, but we hope to expand it to 10, 20 years so that we can see even more dramatic differences. But I'll be able to show you some pretty cool differences already, especially since California has been making its way out of a drought, and this project started at the very end of it. So I'm going to start off. The cool thing about this this 360 photo is that it does show some of the methodology happening. So this hiker is taking the picture. This hiker is holding the meter stick for scale, and we can see these two still photos. But this is going to be the landscape that they're photographing. You can see in this area right here, there's a lot of grasses. These are non-native, and these are not what we would expect in the environment in terms of historical accuracy. The reason for this is that this area is close to where the ranching was, and so it's highly overgrazed, it's exposed to a lot of wind, which makes it harder for the native chaparral plants to embed themselves back into the eroded soil. In this first still photo, you see there's a lot of dead grass and sparse ground coverage. This is because it was taken in August of 2016, which informs me that it's at the end of the drought and that there wasn't a lot of water this year, and that because it's at the end of summer, a lot of this vegetation is probably dead. But if we look 2 years later, we can see that it is significantly greener. We see some coastal stage scrub plants in this middle here where there is sparse ground cover before. There is still a lot of non-native grasses. A lot of the new growth is shorter than the dead vegetation we saw in the previous photo. And there's some more chaparral plants that pop up here and there. It still constitutes a minority. There's still a long way to go in this area. However, I would like to now show you a different area that shows the environment that we would expect of Santa Rosa Island. We see it looks a lot different from the previous waypoint I showed you. A couple of reasons for this are because it's in a canyon, it's not exposed to as much wind, and this is a little bit farther from where ranching occurred, so it's not as overgrazed by feral pigs, cows, sheep. In this still photo, I'm going to show you what we hope to see 10 years down the line in areas like the previous photo. So we can see here that there's a lot of chaparral plants. They're a little bit bigger than what we would see on the mainland. That's just because of evolutionary isolism. And we can see while there is some dead foliage, what's important in this photo is that the non-native grasses are not as prevalent here. Unfortunately, 2 years later, we see that they're a lot more prevalent, probably due to the increased rain. The non-native grasses probably weren't as well adapted to California dry spells, and so they recovered as soon as we had those heavy rainstorms in 2017 and 2018. However, we also see that the chaparral plants have increased their foliage density and are doing a little bit better as well. What this indicates to me is that there are areas of the island where non-native and native are in direct competition with one another and should be prioritized, and there are other areas of the island which are not as in conflict with one another and therefore don't need to be put as high on the priority list. And then, actually, I'll just conclude for you guys. So, as I previously mentioned, in the winter of 2017 and 2018, we saw increased rainfall, which accounts for a lot of the new growth that we see in the plants. There is both native and non-native new growth, which we would expect to see, but we would like to see less of the non-native growth. The reason why photo point analysis is important is because it can help projects such as the Noxious Weed and Eradication Survey conducted by the Center for Invasive Plants and other restoration projects on Santa Rosa Island. And it helps them by determining which areas need their help and which areas don't need to be prioritized quite as much. Another way that this can help researchers to Santa Rosa Island is if they're researching a specific plant species, they can look at this plant species over the island, over several hikes, and they can say, all right, well, I see there's a lot of this plant in this area. I'm going to go to this area of that hike. Whereas this area, I don't see it as prevalently. And so I'm going to see what I can do to restore the plant in that area. Thank you, and I would love to take your questions. Yes.
So what do you want to do in the future with this research? Because it's really interesting. And you still have, what, like 2 more years left? What do you want to do next?
So the nice thing about this project is it almost runs itself. So the national park, when they have teams of hikers that come out to the research station, they essentially give them the spreadsheet and the methodology layout, and they say, go have fun on this hike. And they have reference photos that they can look at to make sure that they're being accurate. As for future directions, we would love to continue to use 360 photography on different hikes other than Lobo, so that we can look at the 360 landscape in addition to the still photos and really get a sense for how the environment's changed. Yes.
What happened if there's not a lot of precipitation or rainfall? Do you think that the native species that you observe are coming back will continue to thrive?
It always depends on the area of the island, especially. A lot of the chaparral plants are actually fed by fog. That is very common on Santa Rosa Island. Poor adapted species like the non-native grasses aren't able to take that precipitation as well. And so we see in some areas of the island, the chaparral plants have really thrived even in the drought because of that fog, whereas in other areas the soil is just too eroded. And so there are restoration projects currently on Santa Rosa Island, such as the Cloud Forest Restoration Project, that are trying to unerode the soil, restore the soil so that plants can establish themselves.
How are you mitigating potential confounds between season and weather or climate?
So as for a season, these are taken twice a year, in the summer, usually around August, and in the spring around March or April. That way we can look at both seasons throughout the years as well. And we do these once a year for 2 years at this point. Sometimes we have more sets of data, sometimes we don't. For this particular hike, we have 200 photos. The reason why I chose the photos that I did is because I chose the first photos ever taken and the last photos ever taken, so I can show you the full span of the project.
So the photos you showed, though, were from 2 different seasons, right?
Yes,
So
yes,
that we would expect more contrast.
yes.
How come you want more than non-native growth? Because you were saying we're hoping that we see an increase in the non-native?
I meant to say increase in native.
Oh.
So what we're looking for is in the second area that I showed you, those big, almost tree-looking plants. We're looking for a lot more of those, or in the first area, the low-lying sage scrub plants. We're looking for an increase of those as well. There should not be complete ground cover of grass on Santa Rosa Island. It should be completely covered in bushes.
The native plants?
Yes,
The original?
the native and endemic.
Okay.
plants.
Yeah, that does make sense.
Are there also people who are using this research for study in the wildlife as well?
Yes, so this is very useful for people doing restoration projects to look at efficiency, especially for areas like the Cloud Forest Restoration Project, which occurs on the Torrey Pines hike on Santa Rosa Island. They can look at erosion patterns in the soil to see how efficient their different methods are for restoring that area.
Including wildlife?
Wildlife, not so much. This is more for flora.
Okay.
It's harder to photograph.
What's the soil type in that area?
It varies across the island. For example, in this background photo right here, it's actually in a marsh. And so as for soil composition, I wouldn't be able to tell you exactly, but there is clay in certain parts of the island. There's more, the area that they're trying to restore in the Cloud Forest is more of like topsoil. most of it has just been eroded down to rock in that area, and so plants aren't able to establish themselves deeper.
Where would you personally want to take this? Like, if you could go outside Santa Rosa Island, where would you personally want to like look at next?
There is currently a photo point analysis project being done in Yosemite, but I think that would be amazing to do photo point analysis in Yosemite, especially in areas where there's a lot of hikes, because on Santa Rosa Island, the areas where there are more foot traffic, we do see a lot more erosion, especially on the sandstone beaches. And so I would want to see in Yosemite the areas where hikers tend to go.
Thank you.